different than when we did them in Algebra 2. We're not going to use your formulas. We're going to solve them as if it's a regular angle, and then we're going to make the double angle part. So first thing we do is solve this as if it was x. So we say, where is cosine positive? First in your 0 to 2 pi. Cosine is positive where your x is positive. We set up our triangle. We notice that opposite the 1 is a 30 degrees. That's pi over 6. So right now, even though this says 2x, we have a pi over 6, and we have an 11 pi over 6. And both of them are plus 2n pi. Good so far? This is what we've been doing. Right? I didn't divide by 2 yet.
How do we get the bottom? How do we get the here?
We have 2. One here, pi over 6, and one here, 11 pi over 6. If you can't do radian measures, then you're going to have to put them in degrees and then use your formula and convert them to radian. At this point, you have to get better with that. Now we've addressed the fact that this is a double angle. So if there were 2 of them in 2 pi, and we doubled it in 2 pi, how many should there now be in 2 pi? In 2 pi, not 4 pi. 4, and then up 2 more pi, we're going to double it again. Then we'll be 8 altogether. So altogether, because we were going to go to 4 pi. But in 2 pi now, since we double it, you should have 4. Now, all we need to do is get this to be x. So we divide by 2. Divide every term by 2. We talked about this yesterday. Put this over 1. You flip it. This becomes pi over 12. Doesn't it have to become a smaller angle if you take half of it? It can't become a bigger angle, so you're not multiplying. You got to be able to flip it over. Now, this will cancel out right over here. So you're left with all solutions right here. This is all solutions. So if I want to know all my solutions, I'm good with that. Now, to get it to be 0 to 4 pi, we know we're going to have 4 and 2 pi, another 4 and another 2 pi. We should have 8. So my denominator, notice, is 12. So I like to start and get all my denominators to say 12. Because when your denominators are the same, you add the numerators. So tell me where this is going to cut off in 12s. Set it to 12s, and it's going to cut off at 48 over 12. Right? And so we know once we reach that point, we're done. We're adding n pi. N pi in 12s is just make it 12 pi. Get rid of the n at this point, because you're just going to keep adding 12 pi, 12 pi, 12 pi. So start with your first 2. Right? Chris?
How do you know that you're adding 12?
Because we're going to add pi to n pi. So we're adding 1 pi, 2 pi, 3 pi. So since we're adding pi to our angles, pi to make this in 12ths would be 12 pi. Would just be 12 pi over 12. Because I want to make it so that all I have to do is add the numerators. I don't have to think that a fraction in my mind all the time. So you start with your original one, which is this and this. And you add 12 to your numerator. That's a 1. So you get 13. You add 12 again, you get 25. You add 12 again, you get 37. If you add 12 again, you get 49. You're out of your limit. That's why we set that limit. And I knew I had to get 8. So I knew I had to get 4 and 4, right? 4 of one, 4 of the other. That's another good way to see how many you expect. Do the same down here. Add 12 to your numerator. Add 12, add 12, add 12. And check it to make sure that you actually have 8 angles, what you anticipated, right? It'll make sense in the long run. You first have to get your all solutions. Without your all solutions, it's a little tougher to figure out where you are from 0 to 4 pi, from 0 to 2 pi, whatever they ask you to find. Can we do this? Is it good? I know it's long. It's long. You got a lot of things going on. Yeah. kind of solve it the way we normally solve it. Then you deal with the multiple angle. Then you deal with adding and adding and adding until we reach whatever 0 to 4 pi or wherever we want to be. Aaron?
So on these, you just put, like, say it says it's positive, you just put every triangle where it's positive on the graph.
Yeah, we never go to the negatives because look, we're only going from 0 to 4 pi. If it went from negative 4 pi to positive 4 pi, I would have to subtract until I hit negative 4 pi. But we normally don't give you that. We normally give you like 0 to 2 pi, 0 to 4 pi. Usually that's like the extent of it that you'll see. All right, the next one. This was a triple angle. You're going to do this the same way. You're going to solve this as if it was just plain x. So, where's my sine negative? My y's are negative here. So third and fourth quadrant. And radical 2 over 2 is my 45-degree reference angle. So 45 goes into 180 4 times. That's my pi over 4. 4 pi over 4, 8 pi over 4. So I'm one more as I come around. So I am 5 pi over 4, and I am 1 less than 8. I am 7 pi over 4. This is my starting point right here. That's my starting point. Can you see it okay over there? I've got a 5 pi over 4 plus 2n pi. Remember, n is any integer. You got to say it somewhere. I should have said it somewhere there. And then you got another one. Now, once we deal with that, we say, okay, now tell me what happens when I take 3 times these angles. So if I found 2 in 2 pi, and I'm going to triple it, how many angles will I find in 2 pi? 6. And if they want me to go to 4 pi, how many angles will I find? 12. I'm going to double 6 because I'm going to do this again around. I should get 12 altogether. So first thing I need to do is divide everybody by 3. Remember your key change flip. That flips it over and you multiply your 4. Remember, it's got to get smaller, not larger. If you multiplied the top and you got 15 over 4, you made it larger. To get a triple angle, you had to make it smaller because we need more. And I'm going to divide everybody by 3 over here. So I get x is equal to 5 pi over 12 plus 2n pi over 3. This was like the example we did in class together yesterday. And I'm going to get 7 pi over 12 plus 2n pi over 3. These are my all solutions. This is my starting point. Now I'm going to add 2 pi, because I'm just going to add 2 pi each time, so I don't need the end in there. So I'm going to add 2 pi over 3 each time. So 2 pi over 3 in terms of 12. So this way I can add my numerators. This goes in 4 times 2 is 8 pi. So I'm technically adding 8 pi over 12 each time. Okay with that? And the same thing before, we set this limit, and this was the same as before, 48 pi over 12. We know we had to do, we said 6 and 12, so we got to do 6 the first time around for one of them, and 6 the second time around for the other one. So that's another way you can stop. So you start with your first 2. And because we converted this, all you need to do is add 8. Add 8 to each numerator. Now when I reach 45, if I add 8, I'm 53. I'm over my 48, so I stop. Go to the second angle that we did, 7 pi over 12. Add 8 to the numerator. And did we end up with 12 of these guys? Yeah. Make sense out of this. If you're tripling your angle, you're going to get more, right? If you had 2, now you're going to get times 3, 6. Now if we ask you to go 4 pi, you're doing another 6. So you have to get 12. Aaron?
I just changed the 2 pounds of table.
I don't have to. I don't. But if you do this, 5 pi over 12, and you add 2 pi over 3 each time, what do you have to do? You have to change your denominator. So we change it once. Because to add fractions with different denominators, you have to keep changing them. So each time I would have to do this, and I don't want to do this. So I change it once. And then all I have to do is just add to my numerator. It gets your pattern going because now your denominators are the same. Yeah, I realize you have fractions in here. Not one of your favorite things. So in these problems, it kind of takes care of everything. It takes care of locating where your actual angles are. It takes care of converting them to all solutions. It takes care of your fractional parts here. It kind of does everything at once. Now, here's another one. This is a double angle in here. Treat this as one right now and solve it. So we're going to treat it as one. So again, we add 1, we divide by 3, we take the square root. When you take the square root, you get plus or minus. So you're in all 4 quadrants. Okay? All 4. Now, remember what we said. When you're in all 4 quadrants, you only need to find the top 2 and add n pi. So if I find this guy, this is 30. This is pi over 6. What's this angle? Short of 6 pi over 6. So what's this angle? 5 pi over 6. So if we start with these 2 and we add pi to them, shouldn't we take care of all 4? Because we can shoot straight across. We don't have to add 2 and pi to each one. We could. It would take us a little longer, but all we have to do is shoot straight across. So remember, here you are. Pi over 6 plus n pi. N is any integer. Then again, 5 pi over 6 plus n pi. I'm rewriting that from over there in case that was difficult to catch. Now my goal is divide everybody by 2. So I get x is equal to, flip this over, pi over 12 plus n pi over 2. 5 pi over 12 plus n pi over 2. These are my all solutions. Any solution I can have comes from here. And then you start. You take your pi over 12 and your 5 pi over 12. We're going to add pi over 2. So the first thing we want to do is change the denominator. So we just add the numerators. What denominator am I going to change this to? 12s. How many 12s is this? 6 pi. So to my numerator, I add 6. Add 6, add 6. And again, we stopped at 48. We stopped at 48 over 12. Chris?
How do you know where you stop?
Well, because we want to stop at 4 pi. So we take 4 pi and we convert it to the same denominator as these guys. So this way I'll know exactly where to stop. Rather than having to say, did I reach 4 pi with this yet? Did I reach 4 pi with this? I take this and I say, as soon as I stop, I reach 48 pi over 12. That's the same as my 4 pi. It's easier if you convert everything to the same denominator. And then you don't have to stop. You're kind of like on a roll, you know? And we expected to get 12, right? Did we say 12? No. We said 3 times 4 is 12. And another 12. So we expected to get 24. What did we expect to get here? 4. We doubled it, it's 8. We expected to get 16. We had 4, and we doubled it. This was not a 3, sorry, this was a 2. So we get 8, and another 8 gives us 16. Okay, did you get up to here? Yeah. Okay, so now we're going to add pi over 2 to each one of these. So take pi over 2 and convert it to your denominator first. So that will give us 6 pi over 12.
And why pi
Well, because it ended up at n pi, right? Because we're going to shoot across like this, not 2n pi. We can come across half your circle, which is pi. Watch, if I took pi over 6, and I added pi, I would therefore get 7 pi over 6. Isn't that this angle right here? 7 pi over 6? So all I have to keep doing is add pi, add pi, add pi on an angle, on my slant. So I only need to list 2 of those rather than list all 4 with 2n pi. If you can get these, this is like everything put together. So everybody has this on their papers. Well, now we do. That's fine. As long as we do now have it on our papers. Okay, here's an angle, and all I asked you was to find me all solutions, not to find me from 0 to 4 pi, because that's a lot of angles in this one. If I'm multiplying by 4, that means I'm going to find 4 times 4, 16 in 2 pi. How many would I find in 4 pi? 32. It's a lot of angles. So all I wanted you to do was get to the all solutions part. Because by now then you should see your pattern of adding them. And maybe we'll just talk about your denominator. So we treat this as an angle, one angle, all the way through until we get to here. Now, here's your 45-degree angle. Again, I can do n pi. So I got pi over 4, and this would be 3 pi over 4. Those are my 2 starting ones. Okay? And I'm just going to add n pi. So when I get to this point, I'm going to divide everybody by a 4. Remember, when you do divide by 4, key change, flip this over. And these are my all solutions, and it should say n, any integer, somewhere. I kept forgetting that. Now, if we were going to do this out, what would we add to your starting angle? Instead of pi over 4, what would we add? What's equivalent to pi over 4? That will help us add to a fraction. If I'm going to string these out again, and I'm going to add something to pi over 16 each time, how would I convert pi over 4 to what? No, what denominator do I want? 16.
Oh,
so how many?
80 times 4.
Yeah, so 4 pi. So now I would add 4 to it, 4 to it, 4 to it, 4 to it. I need a lot of angles for this. Shouldn't they be very small if I'm dividing by 4s? They should be really small, of course. I need to fit 4 in place of 1 angle. I need a lot of angles. But all I asked you for was your solution. Did you have a question, Chris? Go ahead.
When you taking the angles to start with, like the triangles?
Well, that's what you get from here, this part. That's what this part gives you. Where do I locate all quadrants, my x over my r, my x over my r? I know that's my special triangle. We solve it like we would for one angle first. And because it's plus or minus, you have every quadrant. I have to use every quadrant with my plus or minus. Because it says where is cosine positive or negative everywhere then.
So why did you pick the first and second quadrant?
Well, because my first quadrant will help me, oh, I'm missing an axis. My first quadrant will help me locate my reference angle. That was pi over 4. Then I could do this. I could technically name every angle and say plus 2n pi. But we can take a shortcut. From here, we can go here and just say half circle, add n pi. So if I say pi over 4 plus n pi, I will get to this guy. Like if I did this, watch. Pi over 4 plus pi. Convert this to fourths. Now, if I add 1 and 4 pi, don't I get 5 pi over 4? Isn't that this angle right here? So if I do this one, this one, this one, this one, I got to do this one too. So 3 pi will get me across to that. Okay. Only on the slants you can do that, not when they're side by side. Then you got to do 2n pi. All right. This next one, I also asked you just all solutions. So again, treat 3x as one angle. Locate this guy. This again was your special triangle. You recognize your sides. It was a 60-degree reference angle. So this guy is pi over 3, and it'll shoot across to that one. This guy's 2 pi over 3, and it'll shoot across to that one. So start like that, and then resolve your 3x. And again, n is any integer. We have to qualify n, because we could put 2.1 in there, but that wouldn't work. So you need to qualify it for n is any integer. Okay? So if I found 3 of a regular angle, and I'm going to multiply that by 3, how many triples am I going to find now in 2 pi? 9. I'll find 9 angles from 0 to 2 pi. Won't my angles have to get smaller? And look, didn't they get smaller from pi over 3 to pi over 9? Isn't that a smaller angle? Aaron?
Why do you want to put the n pi?
Because you can come clear across here. What's half of your circle in terms of radius?
180. Oh, radius?
Radius. What's 180 equal to? Pi. So instead of adding 2 pi, you're adding pi.
Pi.
Yeah. Okay, now, this next one was actually a half. This is the same as a half x. It's the same process, guys. You still, ladies, you still locate your triangle. Radical 2 over 2. Cosine of radical 2 over 2 is a 45-degree angle. So we've got this guy, pi over 4, and this one, 7 pi over 4. We can't do plus n pi for this, right? Because it doesn't come straight across. So this one has to say plus 2n pi, and this one has to say plus 2n pi. That's how we start. Now, just like before, when you had a 3, and we need to get it to be x, you divide it by 3. If I have a fraction and I need it to be 1x, I multiply it by the denominator, right? I multiply it by 2. Won't that cancel that out? But then I got to multiply this by 2 and this by 2. So when I multiply this, I get 2 pi over 4, which reduces to pi over 2, plus 4n pi. Don't I expect less angles now if I only want half the amount? And I do the same to here. I multiply this by 2, this by 2, this by 2. When I do 14 divided by 4, it just reduces to 7 pi over 2. Keep them reduced. Plus 4n pi. So if you're looking from 0 to 4 pi, if you were, let's talk about this. If you were 2 of them from 0 to 2 pi, regular angles, right? And you took half of 2. What is half of 2? 1, right? I should only find 1 half angle now from 0 to 2 pi. If I go to 4 pi, how many should I find now? 2. And I find 2. Start with your pi over 2. If you add 4 pi, you're out of the range. Because I would make this into 2's. This would be 8 pi. This would give me 2. This will give me at my 8 pi. I can't add that. I'll be out of my range. So you're only going to get 2. It has the same concept, guys. You're just getting less angles instead of more. Instead of twice as many, you're getting half as many. But the process is exactly the same. Anika, you're shaking your head. You okay? Yeah? Good? Alright. It's the same setup, guys. Instead of dividing by 2, you're multiplying by 2.
Are we gonna test on this?
Test on Tuesday.
Yeah.
I think this is your last one, isn't it? Okay, last one. Again, here's my double angle. Solve it like you would a single angle. So therefore, sine in 1 and 3 and 4 negative, 1 and 2 positive. So work your special triangle out. Goes in 3 times. This is 4 pi over 3. This is 5 pi over 3. Now, they're not across from each other, so you can't do n pi. You have to do 2n pi, 2n pi. So now, instead of multiplying, we're dividing again. I got to get that to be 2. Get rid of my 2. I got to get that to be 1x. So divide everybody by 2. And I asked you from 4 pi. So if we had 2 in 2 pi, and we doubled it, we'll have 4 in 2 pi. How many should we have now in 2 pi? So how many now should we have in 4 pi? 8. And we check, and yeah, we have 8. Again, this is important. Reduce this down. So you're getting n pi. When you add n pi, watch guys. I'm just going to add pi each time. I want to convert this to my denominator so that all I have to do is add the numerators. So 6 pi over 6. So if I start with this guy, God bless you, I add 6, I add 6, I add 6. I just keep adding 6. Oh, I'm 3. This one's a 3, sorry. One's a 3, one's a 6. So you're going to have to do this twice. This guy is a 3. So 3 pi over 3. This guy is a 6. So 6 pi over 6. You have to, it's the same thing. You just have to convert your denominator twice. It just reduced down a little bit more. This came back to 4 over 6, so we reduced it to 2 over 3. Remember, you always have to reduce to lowest terms. Well, you have 2 separate ones only because, see this guy up here? When we did he changed flipped. And we multiplied it by here. We got 4 pi over 6. This reduced to 2 pi over 3. So if you left it at 4 pi over 6, yeah, you'd add the 6, but you'd have to go back and reduce everything. So reduce this first and convert that one to thirds. Then this one convert to 6. Just so that you can keep adding your numerator.
So, and then 19 pi over 3, so we're gonna add.
So for this guy, I'm going to keep adding 3 pi to the top. So I start with 2 pi, I add 3 pi. I add 3 pi, I add 3 pi. This guy I'm starting here, and I'm going to add 6. 6, 6, 6. That only happens, guys,